Hey guys, in the previous lecture we performed this, we solved this MCQ until question number 11. Now we start by question number 11 and we continue. So the range of the function f of x equal to sine of pi times the root of the secant of x squared minus x plus 1 is, okay, so we are given the function f of x equal to the sine of pi times the root of the secant of x squared minus x plus 1. Okay, so we want let's say the range of this function, right? So it's clear that one says, okay, let's a function look very complicated, and but one say, okay, good, this is secant, the secant function, like secant of x squared minus x plus 1. This secant here, it only has like it can give or minus 1 or 1 or 0, right? But it will give so it gives minus 1 when x squared minus x plus 1 is negative. Give 0 when x squared minus 1 plus 1 minus x plus 1 gives 0, and it gives 1 if x squared minus x plus 1 is greater than 0, right? So let's try to understand how is this stuff. So let's try to solve x squared minus x plus 1 greater than 0 to see where it is, when it's greater than 0 or not. To do that, I repeat once more, it is a parabola, right? We need to solve an inequality on a parabola, so we find the solution, the possible solution. This will be minus 1 square the delta, this is, okay, excuse me because it wasn't very clear. So it will be minus 1 square, then minus 4 multiplied by 1. Yes or not? I'm just computing the discriminant. So this gives you 1 minus 4, so it gives you minus 3. When the discriminant is smaller than 0, it implies no solution. But so this parabola here never vanishes, never vanishes, excuse me, okay, as there is no solution. So if we draw it, it will never touch the x-axis, and it is an upward parabola, so the only possibility is like this, right? Is there any question? So the question of my student is that can I repeat the step again? So we want to solve this, and we are solving this to understand when the secant will be minus 1, when it will be 0, and when it will be 1. Is that clear? So to solve an inequality, to solve a quadratic inequality, I need to find the roots of this polynomial. To find the roots, I use the delta methods. If you have any other method to use, no problem. The only thing is that you should at the end know what are the roots of this polynomial. But we use the discriminant to do that. The delta is, in fact, yes, but unfortunately we cannot do minus b plus or minus square root of delta because delta is negative, so there is no roots. There is no roots, and the parabola is an upward parabola, so this will stay like this. This means that x squared minus x plus 1 is always greater than 0. never, yes or no? Then, so as it's always greater than 0, so this is always a positive quantity, so the secant of x squared minus x plus 1 will always be equal to 1. If you have secant of a positive quantity, it always equal to 1. And finally, f of x will just be the sine of pi multiplied by root of 1, because f of x was this. Doubts? And this will lead to sine of pi, okay, and that f of x is always 0. We prove that f of x is always equal to, going back to the possible answer, if the function is all, so the range, okay, the range is D, 1 in D, right? Keep in mind that when I say that f of x is equal to 0, the range in fact is a set, not a that all the only value that I will always get will be 0. Yes or not? Okay, this solves the question. So the answer is 11D. Then okay, the question of this my student is that we decided that x squared minus x plus 1 was always positive because of the fact that there was no root, or what? Yes, there are no root, but there are no root, and furthermore the parabola is an upward parabola. In the case, I will take an example. Suppose that you have the parabola minus x squared plus 1 plus 2. This now, look, this minus means that the parabola is downward. It means that if you find the root, if you compute the delta and you see that it's negative, so if you find that there are no roots, in this case it will be like this. But in our case, the coefficient of x squared was positive, so it is like this. But if there was a root, it should cut at the root. Is that clear? Nice. So okay, going back to the PDF. Yes, so we were about to do question 12. Okay, let's start. Let me get a new page. So you are given the function f of x equal to the logarithm of absolute value of, so f of x equal to absolute value of the logarithm of absolute value of x plus 1. No, this no, it is completely wrong. So f of x equal to absolute value. Let me get a new page, please. This pen is getting crazy. Okay, so we have f of x equal to absolute value of the logarithm of absolute value of x minus 1. Okay, here's our function, right? We need look, we have made different proposal. We have the domain and the range, the domain and the range, domain and range, because I remind you that in image it means image or range. Okay, the domain of f is R. Is it possible for the domain of this function to be R? Keep in mind that inside the logarithm you cannot have a negative number, right? So this, what is clear for you is that the absolute value of x minus 1 should for sure be greater than 0. This means that the absolute value of x should be greater than 1. But for this to happen, or x is greater than 1, like 2, 3, 4, 5, 6, 7 dash, yes or not? Or x is smaller than minus 1. This is OR. Because if you take, for example, minus 2, the absolute value of minus 2 becomes 2. That is yes or not? So this end up with no, it's entire from minus infinity to minus 1 union 1 to plus infinity. So this is basically okay. So this is the domain expect to have, and in fact it is R except this inter. Yes or not? And it is the unique answer with that domain, so the answer is C. You will be asking probably, why don't we why don't we check also for the image? But I don't need to check for the image because I have the only domain that is the correct one, right? And so I stop. Okay, the answer is C. Doubts? Okay, something that I used to, I think I told you during the first solving the MCQs of the first week, told you that sometimes you are required to use your mind. Using your mind means to solve problem by using tricks, otherwise you will encounter a lot of trouble if you want to solve any inequality that you have. Okay, but by the way, we are not going to solve it here, but next time we will concentrate on this on finding the domain of this function. Okay, thanks for attending the class, and see you next time.